All right, let's dive into one of the most critical skills you can have for Cisco ACI, troubleshooting the L3 out. This is your fabric's lifeline to the entire outside world, and when it goes down, everything grinds to a halt. So today, we're going to walk through a really systematic, step-by-step process to hunt down the problem and get things back online.
So picture this. Your tenants, your bridge domains, your EPGs, they're all perfectly configured, but nothing can get out of the fabric. It's totally blind. It's a super frustrating spot to be in, and it can feel like you're searching for a needle in a haystack, right? Well, we're going to cut through all that noise and give you a clear, methodical path to find that needle, starting right now.
So here's the game plan. We're going to start with the basics, what an L3 out actually is. Then we'll get our hands dirty with some connectivity checks, we'll verify our routing protocols, and then we'll wrap it all up with a really solid troubleshooting checklist that you can use every single time this problem pops up.
Okay, first things first. Before you can fix something, you've got to understand how it's supposed to work in the first place. So let's get a crystal clear picture of what an L3 out really is and what it does.
At its heart, an L3 out is basically ACI's gateway to everything outside the fabric. We're talking routers, firewalls, the whole WAN. It's a logical setup that uses standard routing protocols to learn about all the external networks and, just as important, to tell the outside world about the networks living inside the fabric. It's got to be a two-way conversation or it just doesn't work.
And this diagram here really lays out all the key pieces. See, you've got your internal servers. They're sitting in an EPG, an endpoint group. The L3 out then gives you what we call an external EPG, which is just a fancy way of representing all the external subnets you want to talk to. And just like everything else in ACI, the policy, the thing that actually allows the traffic to flow, is the contract. Let me be clear, no contract, no communication, period.
So you might be thinking, hey, why not just hook up an external router to a regular bridge domain? Well, this slide nails exactly why that's a bad idea: scalability. If you did that, the ACI fabric would try to learn every single IP address on the internet as a specific individual /32 host route. For a big network, that's just wildly inefficient. You'd blow through your endpoint table limits in no time. The L3 out solves all of this by using good old-fashioned, scalable routing protocols to handle routes the right way. Okay, so we know what an L3 out is. Now, let's look at its job description. It has 5 core responsibilities that it absolutely must perform, and understanding these is really the foundation for all of our troubleshooting.
I want you to think of this as the life of a route. First, the L3 out has to learn routes from its buddy, the external router. Second, it has to distribute those routes to all the other leaf switches inside the fabric, and it uses multi-protocol BGP for that. Third, it has to turn around and advertise your internal ACI subnets back out to the world. Fourth, it can handle transit routing, which is just passing routes between different L3 outs. And finally, step 5, it has to act as the traffic cop, policing everything with contracts. If any single link in that chain breaks, your connectivity is gone.
All right, time to get our hands dirty. We're going to start our investigation at the most fundamental layer possible. Before we even think about complex routing protocols, we need to answer a really simple question. Is the wire, logically speaking, even plugged in? Is the link alive? Okay, your very first, most important test is to SSH right into the border leaf switch and try to ping the external router. Now, it is crucial that you use the correct flags here. V for the VRF, which is like a virtual router inside the switch, and S to make sure you're sourcing the ping from the right L3 out interface IP. If you get a reply back, awesome. That confirms layer 3 is working and your problem is probably somewhere else.
But what if it fails? This is where the real detective work begins. A failed ping tells us the problem's down at layer 2 or layer 3, right there at the connection point. So we've got to start digging. If that ping fails, we drop down to layer 2. Our very first stop is the VLAN config. See, ACI does this thing where it uses an internal system-level VLAN, we call it a PVLAN, which it then maps to the physical VLAN you actually configured on the port. You check this mapping with Show VLAN Extended. You can see right here the internal VLAN 64 is mapped to the external-facing VLAN 51. If that mapping is wrong, layer 2 will never ever come up. So once you've confirmed the VLANs are right, what's next? You have to check for layer 2 adjacency. You use the command show MAC address table for that internal PVLAN. You absolutely must see the MAC address of your external router right here in this table. If you don't, you have a fundamental layer 2 problem. Could be a bad cable, a trunking issue on the other device, something physical.
Okay, so let's say our ping works.
Layer 2 checks out, we know the link is physically and logically alive. Great! Now we have to move up the stack and find out if the devices are actually having a meaningful conversation about routes. Man, this comparison is just perfect. For OSPF, the magic word you're looking for is full. That's the goal. Anything else is a problem. If you see states like X-start or two-way, it means the neighbors can see each other, but they're stuck. They can't exchange routes, and that is a massive clue that tells you exactly where to focus your attention.
Now, even if you see that full neighbor state, you still have to confirm that routes are actually being exchanged. The show IP route VRF command on that border leaf, that's your source of truth. You have to see the external network prefixes in this table. If the routes aren't even getting to the border leaf, there's no way they can get to the rest of the fabric.
So if your OSPF state is stuck and it's not full, where do you even start looking? Well, here are the usual suspects. First, check for an MTU mismatch between the ACI leaf and the external router. This is the classic cause for that X-start state. Then you just got to verify your OSPF area IDs, your authentication settings, and your network types match perfectly on both sides. It's almost always one of these simple mismatches.
We've covered a ton of ground here, from layer 2 all the way up to routing protocols. So now, let's pull it all together into one comprehensive checklist that you can use to systematically knock out any L3out problem you run into.
This diagram right here, this is your roadmap for an end-to-end investigation. Start on the left, at that border leaf. Verify your layer 2 and layer 3 connectivity to the router. Check the routing protocol relationship. Then, still on that border leaf, confirm you're learning the external routes. From there, you follow those arrows for MPBGP and check that those same routes are showing up on the non-border leafs. And finally, you test the return path. Can a server inside the fabric ping out? This method covers the entire path, from control plane to data plane.
Now, what if all your routing looks perfect? I mean, pristine, but traffic still isn't flowing? Well, 9 times out of 10, the problem is hiding in ACI policy. So here's what you check. First, is that internal bridge domain subnet actually checked to be advertised externally? If not, ACI will never tell anyone about it. Second, are your contracts applied right? And finally, and this is a really common mistake, have you defined the external subnets for the external EPG? This tells ACI which source IPs are actually allowed by the contract. If you miss this, ACI will just drop the traffic.
And that really just sums it all up, doesn't it? Don't jump straight into the complex policy stuff. Start at the bottom, layer 2, confirm it's good. Move up to layer 3 adjacency, confirm it. Then check your routes. Then, and only then, do you check policy. Following this layered process will save you so much time and keep you from chasing ghosts.
So the key takeaway here is pretty simple. Troubleshooting an L3out isn't some kind of dark art. It's a method. And by systematically following the layers, checking layer 2, then layer 3, then the route exchange, and finally policy, you can find and fix any external connectivity problem every single time.
So, you did it. You established connectivity, routes are flowing, the fabric can see the outside world. But this brings up a brand new, really important question. How do you control exactly what traffic is allowed to cross that boundary? That brings us right to the heart of ACI's security model, contracts. And we'll dig into exactly how those work in a future explainer.